All right. Today, we're diving into a really fascinating piece of engineering. We're going to strip it all down and look at the pure mechanics, that super intricate, high-speed process that happens inside a firearm the moment it's fired. So let's start with the big question right here. What is actually going on inside that machine in the instant a trigger is pulled? It happens faster than you can blink, but as you're about to see, it's not magic at all. What you're really looking at is this super precise mechanical chain reaction. Our goal here is to slow that whole thing way, way down and just look at it piece by piece. Okay, so before we can get into the how, we gotta meet the main players in this little mechanical drama. Let's start with the key parts of the firearm itself. First up, you've got the most basic part, the barrel. Just think of it like the highway for the bullet. It's a simple, really strong tube that's built to handle incredible pressure and point the projectile where it needs to go. And then you have the action. This thing is the real brain of the operation. It's this complex little system of springs and levers and pins that does all the hard work. It loads a new round, it fires it, and then it gets rid of the empty casing. And of course, here's the part everyone knows, the trigger. It's basically the on switch. That little bit of pressure from your finger is what kicks off this whole powerful sequence happening inside the action. So you've got the barrel, the action, the trigger, and they all exist for one reason, to handle this little guy, the cartridge. I mean, if the firearm is the engine, the cartridge is the fuel that makes the whole thing run. And what's so cool about the cartridge is that it's this perfectly self-contained unit. You've got the bullet, that's the actual projectile, then the case, which is just the container holding it all. Inside, you have the propellant, that's your gunpowder, the energy source, and finally the primer, this tiny little cap that's basically the spark plug for the whole thing. All right, so we've met all the parts. Now let's put them together and see that chain reaction in action. So, the real question is, how do all these separate pieces, the mechanical parts in that neat chemical package, come together to create the bang that sends a bullet on its way? And this whole cycle happens in a flash. First, load. A cartridge gets pushed into the chamber. Then lock. The action slams shut, sealing everything up tight. Next, fire. You pull the trigger. A firing pin hits the primer. That leads to propel. The primer ignites the gunpowder, creating this massive gas pressure that shoves the bullet down the barrel. And finally, the leftover energy is used to extract the now empty case and eject it, clearing the way for the next round. It's like a perfectly choreographed high-speed dance. Okay, so that six-step cycle, that's the core of how pretty much every firearm works. But how it gets ready for the next shot, well, that's where you start to see some major differences in design. This chart here really breaks it down nicely. With a manual action, the shooter has to physically work a lever or a bolt or a pump to cycle the next round. It's all on you. But with a semi-automatic, the firearm cleverly uses the energy from the shot itself to do that work for you. So it automatically loads the next round, but you still only get one shot every time you pull the trigger. And then you have automatic, where as long as you hold that trigger down, the action just keeps on cycling and firing. All right, so we figured out how to launch the bullet, but just getting it out the door isn't the whole story, right? We've got one last piece to this mechanical puzzle, and it's all about accuracy. And that brings us to a really important question. Once that bullet leaves the barrel, what's to stop it from just tumbling through the air like a poorly thrown rock? What makes it fly straight and true? Well, the secret is this really brilliant piece of engineering called rifling. If you could look down the inside of a barrel, you'd see these spiral grooves. As the bullet is forced down that barrel, the grooves grab it and make it spin like crazy fast. And that spin gives it gyroscopic stability. It's the exact same principle as throwing a football in a perfect spiral. That spin keeps the bullet stable in flight, which makes it way, way more accurate. So when you boil it all down, when you strip away all the different styles and models, a firearm is really just a system, a very, very well-designed system for containing and directing an extremely fast chemical reaction. And this basic idea, this controlled explosion, it's something that's been tweaked and refined for centuries. It kind of makes you wonder, what's the next evolution of this technology going to look like?